Hi, welcome back to Prelab for SOC279. We're into week 6, and basically we need to cover a couple of items for you to be able to do hypothesis testing for mini project 2. So let's get into it. As you can see, I have my data set open in SPSS right now, and I'm going to actually work with the syntax file that I started last week. Now, what we need to do here is we need to still recode some of the items that we started with last week because we'll need them for mini project 2. So I'm just kind of resizing my windows here so we can kind of be able to see these things happening at the same time. All right, so if you remember, I'm working with the ANES data set, and I'm using the dependent variable Ft_t. This is a continuous measure. It ranges from 0 to 100, and it is a feelings thermometer item. This is essentially where respondents were asked how they felt about the Tea Party, and they were offered a chance to score 0 to 100, where 100 was a very positive or warm feelings towards the Tea Party, and scores of 0 and 1, 2, 3, 4 were very low towards the Tea Party, or negative towards the Tea Party. So just because we did it last week and we want to see what it looks like, that is what the frequency distribution looks like for the Ft_t item. Now remember, you don't want to just copy and paste this into your file that you're going to turn in because first of all, you'd have to talk about all this, and that's a lot to talk about, but also because this won't fit onto one spreadsheet. So, or I'm sorry, it won't fit into one page in the document. So what we're going to do is we're going to recode this item. We're going to basically make this into a 4-category variable. And as you can see, scores 0 to 25 are going to be 1 on the new item, 26 through 50 are going to be 2, 51 through 75 are going to be 3, 76 through 100 are going to be 4. And if you need a reminder of how exactly you do that, you can just go back to the week 5 pre-lab because I talk about actually recoding there. We're going to kind of speed through it. So we're going to highlight and run this. And then we're going to go into the variable view for just a tiny second because I want to do something that's going to make my life a little bit easier when it comes time to talk about these things. And I'm going to go into the variable view and I'm going to change the labels for that item. So as you can see, I'm in the variable view, and see how there's this column here called values? If you hit that little blue button, it has the ellipsis on it, we can define what our value labels are going to be. So this is where I would say everything that was coded as a 1 in our new item, we want that to show that those were scores of 0 to 25. And then 2 got coded as 26 to 50. 3 is going to be 51 to 75, and 4 is going to be 76 to 100. All right, we do that, and now when we run our Ft_re item and we get the output, the variable labels are already input here. So I can just pretty much just copy and paste this into my Word file for mini project 2, which is always really nice. All right, so moving on. We need to have a couple of independent variables to work with in order to do hypothesis testing. So we're going to work with education as an independent variable. We're going to work with the dem_edu group item. Now, if you see in this frequency distribution, education is coded as a 5-category item, where 1 equals less than high school education, 2 is a high school education, 3 is some college, 4 is college degree, and 5 is a graduate degree. Now, because I'm going to do a t-test, I need to have one of my independent variables in a two-category item. Because if you remember, a t-test or a means test is something where you're looking at a dependent variable and two categories or two groups. So in this case, when I recode, I want to be able to compare one group to another. This recode command that I have for dem_edu group is going to create a new item called dem_ed_re. And this item is going to be coded 0 and 1. If they are a 1, a 2, or a 3 on the original item, they're going to be a 0 in this new item. And if they're a 4 or a 5, they're going to be a 1 on the new item. So we're going to go ahead and run that. And then we're going to go ahead and do the frequency distribution on that. And you know how I feel about labeling stuff. So we're going to step back to this variable label and change that so that 0 equals some college and less, and then 1 is going to equal college, degree, and more. All right. All right, so now when we go back and rerun that, we will see that reflected in the new table. So run, and there are new labels. It's very nice. All right, so the other thing we're going to do is we're going to go ahead and set up our second independent variable, and we're going to make this a 3-category item because in order to do a hypothesis test, I need to, since I want to use my continuous dependent variable, I need to have a 3-category item for one of my other variables. If you remember, one of my other variables was political party identification. And that item in the ANES data set is PID_X. And as you can see, what I'm going to do here, let me just step back and code this. I am going to show you what it looks like just to remind you why we need to recode it, or why we want to recode it, okay? So frequency distribution on PID_X shows that that is a 7-category item. It ranges from strong Democrat down to independent leaning Democrat, independent, and then independent leaning Republican, and then strong Republican. So with that in mind, we're going to actually recode it into a 3-category item. Remember, I don't have strong feelings about whether or not this is going to be, I don't want to compare strong Democrat to not strong Democrat and independent leaning Democrat. I just want all the Democrats to be together in one group and all the Republicans to be together in another group. And the reason for this is that, because the reason, you want to have this kind of thought process, because while it may be easier just to run it and say that you're going to do analysis and look at strong Democrat compared to not very strong Democrat compared to independent leaning Democrat, I'm going to have to talk about all of this once I've created the tables, I put them into my document. And I don't want to spend a lot of time talking about all that. So what I'm going to do right now is I'm just going to recode it into a 3-category item. And, that's just, sort of my process, like the way I like to go about it. Remember, we said that 1s were going to be Democrat, and 2s were going to be independent. And 3s are going to be Republican. So now again, when I do this analysis part, you see that I now have Democrat, Independent, and Republican all labeled. And that's nice because when we do our our crosstabs, you see that instead of these just being the value labels here, they actually have variable names. So I can say among individuals with some college or less education, 24.3% scored the Tea Party 1 to 25, 48% scored the Tea Party between 26 and 50, 17% scored the Tea Party at 50, between 51 and 75, and then 9% scored the Tea Party between 76 and 100. All right, so that's nice. So cross tabs, and remember, you need to do 5 frequency distributions for the MAPE Project 2, 1 for each of your variables. And then in terms of cross tabs, you want to use your recoded dependent variable if you're using one of those ft_t items, and each of your other variables. So you'll end up with 4 of those. And then the other thing we need to do is we need to do a hypothesis test. Now, if you remember, we talked about last week that T-tests are the things that you should use if you're going to be comparing 2 groups. And we talked about this week, if you're going to be comparing 3 groups or more, you should use an Ftest. So as you can see, we've made an independent variable with 2 groups, which is education. And we've also made an independent variable with 3 groups, which is political party identification. So I can do a T-test on one and an Ftest on the other. And if you remember correctly, when we do the T-test and Ftest, we simply go up here to the Analyze tab and compare means, and we do an independent samples T-test. And here you're going to want to put your dependent variable in this big square up here and your independent variable in this little space down here. So remember, we also need to use a continuous measure here because of sort of requirements for a T-test. For us, that means we need to have a continuous measure. Our independent variable, though, which is in this case dem ed re, we're going to use that for the grouping variable or the independent variable. We need to also, before we can go on, see SPSS won't let us click on the OK. That's because we need to define the groups. Remember that we coded this variable 0 and 1, so we're going to add those codes in there. Once we've done that, we can run it. And I'm going to maximize this window so we can see what we did here. The T-test output generates means for each of the groups. Individuals with a college degree or less, individuals with some college and less education, they scored the Tea Party at 43.5. And the individuals with a college degree or more scored the Tea Party at 37.8. And then what we have down here is we have Levine's test for equality of variances. Don't worry about this. Don't worry about interpreting this first F-test or this significance value. What we're interested in is a significance value for the two-tailed test, which is here. And what this does is this tests the null hypothesis. If you remember, the null hypothesis is a statement that we think is opposite of what reality is. All right, so we think that there's probably a difference between individuals with higher levels of education and individuals with lower levels of education in terms of their support for the Tea Party. So we're going to set up the null hypothesis to be that people with higher levels of education have the same agreement or same mean score on Ft_t as people with lower levels of education. So that's our null, and with these results here in this significance test of 0.000, that's very significant. And so we can say that we have enough evidence to reject the null at 0.000 level of significance, or 0.000 alpha level, which is, it's very strong. It's great. Now remember, once you've generated that test in SPSS, you can right-click on the code that's generated and copy it. And then you kind of stick it into your syntax file, because once you do that, you don't ever have to rerun that code again. You can just highlight it. I'm sorry, you never have to use a drop-down menu to get that. You can just highlight it and run it, which is nice to be able to do. All right, so that gives us our T-test. Remember, we did that because we had a dependent continuous variable, and we were comparing two groups. We were comparing people with lower levels of education to people with higher levels of education. So what we want to do now is we're going to do an Ftest because our political party identification item is coded into 3 categories. We have Republicans, Democrats, and Independents. So we can get there by going to Analyze and then pull down the menu to one-way ANOVA. All right, and here you're just going to find the variables that you're working with. Remember that that dependent variable needs to be the original continuous measure for Ft_T. You wouldn't want to use the item that you just recoded because Ftest requires continuous data as one of its assumptions. All right, so Ft_T and then our party ID, and we run it. And before we start looking at the interpretation for the ANOVA table, I'm going to also do just a means report where you go to Analyze and compare means, and just click on means there. And here we're going to get the means for each of those political parties. I just gotta find it. Ft_T. There we go. Okay. All right. So if you remember, what we're trying to do with a hypothesis test is we're trying to come up with a way to say that the null hypothesis is not, it does not reflect our data or our problem or our relationship with the variables, whatever. Okay. So one way to do that is to say, that the mean score for Ft_T will be equal for Democrats to Republicans and Independents, that they're all basically going to have the same mean score on Ft_T. Okay, that is our null hypothesis. So when we do an ANOVA, what we're testing is whether or not that's the case. And if you want to kind of talk more broadly about it, what it is it's asking, do we have enough evidence to say that there are not significant differences between the 3 groups? All right. So if you look at the means report I just generated, we see that Democrats have a mean score of 29.8, Independents have a mean score of 41.82, and Republicans have a mean score of almost 60. And so with that in mind, how we would kind of think about our hypothesis test is, are these differences significantly different enough in order to say that this is not some type of artifact of data? And what we, in our ANOVA table up here, we have a significant Ftest and a significance value of 0.000. What this tells us is that we have enough evidence to reject the null hypothesis. And looking at these mean scores here, we can see, well, this makes sense. We have the ability to, or we have enough evidence to, at the alpha level 0.000, to reject the null hypothesis. The mean score for Democrats, Republicans, and Independents vary significantly. Or we can just say they're not equal. Either one of those works. I would also, you don't have to always run the means table, but some people like doing it because it gives them a way to think about their analysis, because this ANOVA table just tells you that they're significantly different. It doesn't tell you what the actual means are. And because they are so different here in the means table, we could, if we had seen that without the ANOVA test, we might have said, oh, they might look kind of different. But, we're in statistics. We don't eyeball things. We have a statistical test in order to be able to say, oh, these things are significantly different. So that is what we do. Make sure you grab the code for that means test and paste it into your syntax file. That way you don't have to, go through the steps again. It's always there. You're going to need to have 4 hypothesis tests in addition to your 4 crosstabs and your 5 frequency distributions for mini project 2. And that is all. Please do reach out to me if you need any help, and good luck. Thanks.